Okay, quick space riddle. Why is the search for life in the universe like a tree? Because you're always looking for a place to plant it. You know, plant it, planet. Okay, settle down. Anyway, water is the basis of life in any part of the universe, so potentially inhabited planets must have liquid water on them to support life. An incredible number of circumstances must come together for this. The planet must be in the habitable zone of the star. Then the temperature and atmospheric pressure on the planet's surface will be suitable for simple life forms to begin to evolve. A little closer to the star and the water will evaporate, leaving no chance for oceans and seas to form. This is what happened on Venus. It has a size and mass similar to the Earth, but it's too close to the Sun and no life can exist on its surface. Too far from the star, and the planet becomes too cold. Water can only exist in the form of ice on the surface, and there just might be liquid water deep below. Neptune is one example of this. In addition, the planet must be solid and have an atmosphere that protects it from solar radiation and allows living organisms to breathe. In our galaxy alone, there are countless stars. Really, you can't count on them. Near each one of them may be a planet. They're called exoplanets, and some of them may be in the habitable zone and have everything for life to form on them. From a list of 4,500 known exoplanets, scientists have identified 24 that can be superhabitable. This is the type of planet that is suitable for the existence and evolution of life, even more than the Earth. Such planets must be twice as massive as the Earth and 1.3 times larger. A bigger size means stronger gravity and a denser and warmer atmosphere. This will ensure a greater diversity of all living organisms on the planet. In addition, we should pay attention to the host star around which the superhabitable planets will orbit, and there should be a McDonald's nearby. Ideally, it should be smaller than the Sun and have a lifespan of at least 15 to 30 billion years. For comparison, the lifespan of the Sun is under 10 billion years, and it took about 4 billion for complex life forms to appear here. Stars such as the Sun can simply run out of fuel before life can develop on its exoplanet. Scientists suggest focusing on dwarf stars. They're smaller and less luminous than the Sun, but their lifespan can be between 20 and 70 billion years. This will give living organisms enough time to develop and evolve. Climatic conditions on superhabitable planets will also be different. The average temperature should be 8 degrees Fahrenheit higher than on Earth, and there should be more water in the form of clouds, liquid, and humidity. These conditions are the most favorable for biodiversity, so the whole planet would be looking like tropical forests on Earth. All 24 candidates for the title of Better Than Earth, are more than 100 light-years away from us, and with the advent of the new generation of telescopes, we'll probably be able to find out exactly if there is life there and if the conditions there are suitable for humans. Now, let's take a look at the potentially inhabited exoplanets. Teegarden B. It's an exoplanet that orbits a red dwarf star about 12 light-years away from the solar system. Typically, red dwarfs can emit flares that blow away the atmosphere of the planets in its orbit. But this host star is calm and relatively passive. Teegarden B has almost the same mass as the Earth. It makes a complete circle around its star in about 5 days. Yep, you got it right. A year on Teegarden B is less than a week on Earth. Hold on to your hats. The furthest potential inhabited planet is Kepler 1638b. It's in the constellation Cygnus, about 3,000 light-years away from us. It belongs to the Super-Earth class. It's twice as wide and 4 times as heavy as our home planet. The gravity on it will feel much stronger. Even a normal jump will be much harder for you than on Earth. Although, if this planet is really inhabited, local life is used to such conditions. LHS 1140b. This planet is very rocky and solid. Although its size is only 40% larger than the Earth, it's 7 times as massive. It has a strong gravity of 3.25 Gs. For comparison, when you take off on an airplane, you experience an overload of about 1.5 Gs. So on this planet, you'd barely be able to stand on your feet. Because of its large mass, this planet has a thicker atmosphere, and because of the greenhouse effect, its temperature can be above 19 degrees Fahrenheit, and it rotates around its star quite quickly. It makes a full circle in just 24 days. And now, let's look at the constellation Aquarius. Here's an ultra-cold dwarf, TRAPPIST-1. A small planet orbits in its habitable zone. It's 3 times lighter than the Earth. Its temperature is similar to ours, but the gravity is half as weak. But we would still feel comfortable there. Remember the people that went to the moon? There, the gravity is only 16% of the Earth's. That's what makes the astronauts move so funny. Kepler 452b is in a system that resembles the older sister of ours. The host star is only 11% older than our Sun and is almost 2 billion years older. The exoplanet itself is 6.5 billion years old, compared to 4.5 billion of Earth's. But these sisters are very far from each other. If you travel at the speed of the New Horizons spacecraft, it will take about 26 million years to get there. So bring a big lunch. This is the closest exoplanet to us, Proxima Centauri b. It orbits the red dwarf Proxima Centauri, which is the closest star to the Sun. This planet is just 4.2 light-years away from us. Its size and mass are very similar to those of the Earth. It probably has an icy structure, like Neptune. Although Proxima Centauri is the closest star after the Sun, we can't see it with the naked eye because it's too dim. So, all these planets, including the 24 that scientists have recently found, are in the habitable zone of their host stars. And, in theory, we can colonize them and make them suitable for human life in the future. But here we'll have to solve one big problem. Even the nearest exoplanet is too far away for us today. Our modern rockets can fly at 5 times the speed of sound, and even at such speeds, it will take us more than 100,000 years to get to Proxima Centauri on one of them. Well, we need to come up with something a bit faster to travel to a new home on one of these exoplanets. And perhaps scientists already have the answer. Warp drive. Ooh. This is a piece of technology that will allow us to manipulate space and time. It creates a kind of a bubble in which the normal laws of motion don't work. So the spacecraft will be able to significantly exceed the speed of light. And this isn't science fiction. Humanity already has such technology, although just in theory yet. It's Alcubierre warp drive. And no, I didn't make that up. Since no object that has mass can travel at the speed of light, we need to do one trick. The spacecraft has to move by compressing the space in front of it and expanding it behind it. Thus, not only the ship is moving, but also the space-time inside this warp drive bubble. And the maximum speed can be 10 times that of light. But to warp the space-time, the ship must be incredibly large. And to power it, we'll need the amount of energy close to what the whole planet of Jupiter generates. Still, recent calculations of NASA's Jet Propulsion Lab show that the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round, as it was thought before. It can be more donut-shaped. Ah, donuts. This will greatly simplify the design and construction and will make it possible to test this technology on a spacecraft the size of a Voyager 1 probe. Even though it still seems impossible, scientists are already saying that there is hope. And while we don't know what technology will be used, in 2069, NASA plans to launch its first interstellar mission to explore potentially habitable planets outside of our solar system. Various rumors say that the speed of light can be achieved with laser technology. If the probe is very small, it can be launched to the Alpha Centauri star at almost the speed of light. There are also 2 other alternatives to power spaceships. These are nuclear energy and energy from matter and antimatter collisions. Ooh! These technologies are still a mystery to humanity, though. Well, for the time being, stay tuned.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation. How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are two ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP-121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP-121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP-121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP-121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.